climate change.
Okay, no, I didn't say climate change. You said climate.
Well, I want to argue with climate.
Well, we're not going to do that. Okay, that was a good. So, what we need to go over today is climate. What it is, what are the components of it, so what would we consider to be part of climate, okay, and then we're going to look at the factors that affect it, okay, why climate in Calgary or Okotoks is different than the climate in Vancouver or St. John's, Newfoundland or something like that, okay. Now, the reason I picked those cities is because, no, they're all actually about the same latitude, okay, they're all about the same distance from the equator, but their climates are considerably different. Okay, Vancouver's climate is considerably more mild than ours. Okay, ours is quite harsh. Okay, it can be very hot in the summer. It can be very cold in the winter. It's also quite dry. Okay, if you go to St. John, Newfoundland, they can have very harsh winters, but they get a lot of snow. Okay, they don't get really warm during the summertime, and they get a lot of precipitation. But we're all the same distance from the equator, so we got to look at kind of what are some things that can affect the climate of an area, because that's what we're going to be doing our activity on starting tomorrow, and then a little bit after the Christmas break. It's going to be on the factors that affect climate and kind of how they do that. All right, so we're going to look at those two things first: affect the climate on plants, animals, and humans, energy inputs and outputs of various environments, and then we're going to look at what climatograms are. Okay, they're basically a graph that shows temperature and precipitation by month for a location. Okay, and that's part of the activity that we'll be working on as well. All right, so if we were talking about climate, okay, what are some things that we would talk about if we were talking about climate? Besides climate change. That's not it. I mean, what are the parts? Temperature. Okay, so let's be more specific than weather. Okay, maybe humidity, yeah.
The world getting hotter.
Precipitation. There's one that people generally miss. Light, yeah. Actually, I put my eye at the one that shouldn't have been up. Wind. Okay, the four major components of climate are temperature, precipitation, light, and wind. Okay, those are the four things that we would consider part of the climate. I mean, think about if you open up your weather app in the morning to see what it's going to be doing. Okay, you want to know how warm is it going to be. Okay, is it going to rain, snow, hail, whatever, and especially in the wintertime, is it going to be windy? Because if it is, it's going to feel a lot colder, right? Now, the other thing that's usually listed there is sunrise and sunset, or whether it's going to be sunny or cloudy. Okay, that's light. Those are the four components of climate, and they're what we consider to be weather, basically, main parts of weather. All right, so climate, by definition, is the prevailing weather conditions at a location. Okay, it's not the averages. People get that confused. Okay, if climate was the averages of an area, I would describe the climate in Okotoks as this. The average temperature in Okotoks is about 6 degrees Celsius. Okay, the wind is typically from the southwest at about 25 kilometers per hour. There's 12 hours of sunshine and 12 hours of darkness, and it rains about 0.2 millimeters per day. Okay, is that an accurate representation? No. I mean, we live in Alberta. If you don't like the weather, wait 5 minutes. Okay, we know how it works here. Okay, weather is always changing. So it's the prevailing weather at a location. A better description of the climate of Okotoks would be something like, okay, there is distinct seasonality in Okotoks. Okay, we have two seasons. We have summer and winter. Yeah, those transition times are not really real seasons for us. Okay, but because of that seasonality, the amount of sunshine that we receive does change. It is typically dry here, with the bulk of our precipitation coming in the late spring and early summer. Okay, and then obviously we have very cold winters and quite hot summers. Okay, but wind, we could actually use the averages, typically out of the southwest, somewhere around 15 to 20 kilometers an hour. Okay, that would be a good description of what the climate of Okotoks is like. Okay, it's much more accurate. Okay, so major components. Now, these major components contribute to local weather. Okay, the changing of weather and things like that. Okay, we know that in the summertime, sometimes we see these things build up. Yeah, special kind of clouds. Cumulonimbus, good. You all remember your grade clouds. Okay. So, cumulonimbus clouds are the ones that give us the big thunderstorms, the ones that produce damaging hail and strong winds and all those other things they warn you about when there's a thunderstorm warning. Okay? Now, the reason we get those is because these components interact in the right way, or are present in the right way. If we're going to get a big thunderstorm, a really powerful one that could produce tornadoes and hail and all that kind of stuff, we typically have to have a certain set of variables present for that. It's got to be reasonably hot. It's got to be pretty humid. There can't be a lot of wind during the building process. Okay, so it's typically a fairly calm day. Okay, and so we got temperature, precipitation. We're going to get light and not a lot of wind. That will lead to this. Okay, that'll lead to the precipitation, but there has to be the right set of factors. Okay, in the wintertime, those factors aren't present. That's why you don't get thunderstorms, except in incredibly rare situations where you can get a thunder flurry. Okay, I don't know if you've ever seen, there was like video on the Weather Channel a few months back. This guy who'd been a weather, like a meteorologist on TV for his entire career, like 35 years. Okay, he'd never seen a thunder flurry, and the conditions were perfect for one. And he was out on location, and it's snowing like crazy, and all of a sudden there's lightning and thunder, and the guy goes ape. Like he just goes absolutely ape. Like he drops the microphone and he's running all over the place like a crazy man because he's so excited that he got to see one of these things. That's how very rare they are. Okay, but most of the time you need these kind of conditions to build up. In the wintertime here, the type of storms we get are usually the interaction of different types of air masses. Okay, we get some moist air coming over the mountains, okay, from the Pacific Ocean, and it interacts with some kind of massive polar high pressure area that's full of really cold air. Okay, they interact right along the edge of the mountains, and that's when we get snow days. Yeah, let's go. Because you guys are in a very interesting time. Because we've had 3 of those this year.
Yeah, because of climate change.
Yeah, right. Okay, so what we see here, guys, to build this up in the summertime, to build a thunderstorm, is we have a lot of hot, moist air that's rising. Okay? As that hot, moist air rises, it eventually gets up into cooler parts of the atmosphere where the water vapor will condense back into a liquid form. Now, if it's an incredibly hot day, there's a lot of updraft. Okay? And so the little droplets of water that have formed don't fall back down to the ground. They keep getting pushed up by the hot, moist air that's continuing to rise. And so these clouds continue to build up taller and taller and taller because we're not allowing the water droplets to fall back down. The more times a water droplet cycles through and goes a little bit higher, the bigger it gets. Okay? If it goes through enough times, it'll start to freeze. And as it starts to fall, some of that moist air that's still rising will condense and freeze onto it, making it get bigger and bigger. That's how hailstones grow. Okay? The more times a water droplet goes through this, the more likely it is to become a hailstone, the more likely it is to become a large hailstone. Okay? And eventually the updraft is just not strong enough to hold all that stuff aloft anymore. There's a massive pressure shift, and you get the hail, and that's also what causes the tornado. There's such a massive difference in pressure between the top of the cloud and the bottom of the cloud that it just creates this funnel through which the pressure is equalized very quickly. Okay? All right. Yeah, so that's kind of what we got again, have the right combination of these components. Right? So, should you know the 4 components? Yes. Definitely. Okay? Because what I might ask is something like, describe the components of climate in St. John's, Newfoundland as they would exist. Okay? And then I might even go further and say, what factors would cause them to be like this? Now, the factors are what we're going to talk about next. All right? So that's the context in which you would need to know the 4 components of climate. Okay, number 1 factor affecting your climate is how far from the equator you are. Right? So your latitude is your number 1 factor affecting climate. Reason for that, the further from the equator you are, the less direct and thus less intense the sunlight you receive is. If you are right at the equator, the sun is essentially directly overhead at all times. When the sun is directly overhead, it's very intense and is giving you a lot of energy. As you get towards the poles, it's less direct, it's less overhead, and so as a result, we get less intense sunshine. This is exacerbated by the fact that the Earth is tilted. That's what gives us the seasons, by the way. It's not the fact that the Earth gets closer to the sun. Okay?
But also, like, it's like the same temperature here in like Mexico. Are you going to get way more tan if you're outside Mexico as closer to the equator?
Not always, no. Generally, yes, but not always. Reason being is it's as hot here as it is in Mexico. It's summertime here, and we're getting very intense sunshine during that time. Okay, so here's what happens. At the equator, okay, all these yellow bars here all represent equal amounts of solar energy. Okay, at the equator, that solar energy is concentrated in an area as long as this line. Okay, as I move further north, okay, that same amount of energy is now spread over a larger area. Okay, further north I go, the worse that situation becomes. The same amount of solar energy is now spread over an even wider area. So the sunshine is less intense, so it tends to be less warm. Everybody all right with that idea? Okay. Now, the other problem is that the Earth is tilted. And so right now, in fact, in 2 days from now, on Saturday, okay, we will be tilted as far away from the sun as possible, 23.5 degrees. Okay? So that line that I've just drawn there is the Earth's axis. Okay? This would be the North Pole. Okay? This would be the South Pole. Now, that means that, okay, the sunshine, like we're tilted even worse than this picture actually is. Okay? If I can do this. Okay, so it's tilted even worse. Okay, so now that same amount of sunshine is over an even wider area in the wintertime. Okay, so it makes the amount of energy we receive even less. Now, on top of that, not only are we receiving less direct sun, and you can see that. Okay, like you can see the fact that the sun is less direct, because when it goes across the sky now, okay, how high in the sky does it get? Not very high. Okay, this is the worst time of year for driving, because your sunshade doesn't even work half the time. The sun is so low on the horizon that it shines right through underneath your sunshade. You guys probably don't like yet because you haven't driven very much. That's true. Okay? This is one of the worst times of year to drive. Okay? Especially if you're driving, like if you lived in Airdrie and you were driving in, like if you're driving south, it's really bad. Okay? In the summertime, not nearly as big a deal, okay? Because in the summertime we're tilted towards the sun, and the sun is far more directly overhead, okay? And you can see it goes over this way instead of just in this little pathetic arc, okay, over the southern sky. All right. On top of that, because we're tilted like this, how long do we spend in the sun? Not as much, right? Days are really short. Okay. In the summertime, the situation is reversed, okay? And now we're tilted towards the sun. So we spend a lot more time in the sunshine. If you live in the Arctic Circle, you're always in the sun. Light for 24 hours. Of course, right now in the Arctic Circle, it's dark for 24 hours.
Imagine that.
Okay? And they were just saying, I just heard the other day that in Yellowknife, it was so cold that they had to suspend their snow removal because their trucks couldn't run, their plows. Okay, it was that cold. It was minus 55 with the wind chill. Okay, and part of the reason for that is the sun doesn't come up. Okay, there's not going to be any input of solar energy. It's just dark. Okay, there's no chance for anything to warm up and melt. Okay, because there's not going to be any sun.
Would de-icing, like putting salt in there, might even work if there's no sunlight?
Salt will work. The sand won't. Like when we put salt and sand on, sand helps with traction, but it also makes the snow darker, which helps it absorb more solar energy. Helps it faster.
My family framework's up there and you can't even weld right now because these cores break.
Yeah, we've done it. It's just everything just snaps when it's that. That's when they can do those hot water pictures, you know, where you throw the hot water, it's so cold it freezes before it hits the ground. Okay. Another interesting thing is you can tell it's below minus 50. If you spit, it'll crack because it'll freeze before it hits the ground. Yeah. So that's one of the ways you can check the temperature. Spit, if it cracks, it's frozen before it hits the ground, you'll hear it. Okay? Yeah. Of course, it might also be frozen to your face because, you know, your best. Okay, so latitude, number one factor affecting climate because of the relationship between the tilt of the Earth, okay, solar radiation, okay, all of that kind of stuff. The Earth is constantly going back and forth. Now, our 23.5 degree tilt is an average. It can be more than that. It can be less than that by a small amount. The moon does actually stabilize that, okay, and keep it around 23.5 degrees. Okay, without the moon, the Earth's it would fluctuate a lot more. Okay, they actually see that on Mars. Mars, because it has just the two small moons, its tilt fluctuates a lot more than ours does. Okay, because there's no stabilization. All right, if there's time, I have a video. If there's time, I'll show it to you. Okay, next thing, altitude. Okay, altitude is a major factor affecting climate because it can also affect temperature. The higher up in the atmosphere you go, the thinner the atmosphere becomes, and the less able to hold on to heat it is. Okay, which is why snow stays on the top of mountains much longer than it stays down here. Okay, on average, temperature decreases by 6.4 degrees Celsius for every 1,000 meters of altitude gained. Okay, if you've ever spent any time backpacking or climbing in the mountains, this is very true, very evident. Okay, my father and I did a backpacking trip here at Mount Robson. Mount Robson is the highest peak in the Canadian Rockies. Okay, to give you some idea, this picture probably take before you're born, but this is July 8th. Okay, so July 8th, and you can see where we were. There wasn't any snow; it was raining. Okay, but the top of Mount Robson was probably another, I want to say 1,500 meters, maybe more, okay, above where we were. It was about 2 degrees Celsius where we were. And but you can see that up top here, it's a snowstorm. Okay, it was a rainstorm where we were. Okay, it was a snowstorm up there. Where our campground was, which was another 1,000 meters down from where we were, it was about 12 degrees Celsius. Okay, so there's a massive decrease as you go up. Okay, in fact, there were people that were making summit attempts that day that perished. Okay, that's with most mountaineers. I got to get to the top is more important than I got to get back down. Okay, that's how you die on a mountain. Okay, you want to die on a mountain? Make getting to the top more important than getting back down. That's how you die on a mountain. Okay, the issue was that wind came up really, really bad. It was a complete whiteout. With very strong, like 80, 90 kilometer an hour winds, and they just couldn't see what was going. No, they were walking. They weren't like climbing with ropes. They were.
Yeah, but they couldn't just like.
You can't see anything.
You can't see anything.
I couldn't see
Just
Mr.
walk
Crunch.
over the edge.
Oh, walked over the edge. Oh.
Or that's what we everyone assumed because they ended up there. Okay, so that's the effect of altitude, and that's another reason why here in Calgary, okay, it's cooler typically, okay, than Vancouver. Now Vancouver's got other things that help it stay warmer, but it's at sea level. Okay, it's 1,100 meters lower than here. Okay, right here in this school, we're I think 1,094 meters above sea level. How do I know? Because they used to have a watching on my altitude. And it always say 1,094 meters above. Okay. All right, so we're over a kilometer above sea level here. Okay, so a place that, for all intents and purposes was equal to us, they would be about 6.5 degrees cooler if it was at sea level. All right, another factor affecting climate, or a couple more. Okay, distribution of land and sea. That is, are you close to the ocean or not? We're not. Okay, we're on the other side of the mountains. Okay, and we're in what would be considered a continental area. Okay, we do not have the influence of a large body of water nearby. Okay, water has a huge effect on your temperature because water can absorb and give off large amounts of energy without changing its temperature very much.
Do you think that's just the ocean, or is it also like the Great Lakes?
Great Lakes can have an effect. That's why places like Buffalo will get like lake effect snow, right? Like they wake up in the morning and there's been 6 feet of snow fall overnight. Yes, it can have an effect, not the same as the ocean. Okay? It's more of a localized effect under certain conditions. Okay? But yeah, the ocean can have a huge effect, especially if that part of the ocean is influenced by certain types of ocean currents, okay, bringing in different types of, or different temperatures of water. Okay? If you go to Newfoundland and you go to the coast, the ocean is cold. You go to Vancouver, the ocean is cold. Okay, you're not going to be you can always tell Canadians when you go to Hawaii and Mexico and places like that, we're the ones who approach the water suspiciously. Okay? Like, you see everybody else is running into the water, Canadians like, oh, it's gonna be cold. Okay? We're just used to that. Water's always cold. Okay? But yeah, in our oceans in Canada are colder. But on the east coast, it's worse because the North Atlantic and the Labrador currents influence the temperature of the water there. So you usually have much colder water going by the coast in Newfoundland. In fact, a lot of the ocean will freeze, okay, around the coast in Newfoundland. Whereas on the west coast, okay, we get what's called the subarctic current, but it's much warmer. Even though the temperature of the water is not a lot different, okay, it's bringing in this fresh, warmer water, and so we don't typically see freezing along the coast by Victoria and Vancouver and places like that. Okay, so their climates are a lot more mild because they're close to the ocean, and the ocean acts like a heat sink. Okay, and so it can hold on to this temperature, or hold on to this energy, and then the second law of thermodynamics will kick in. If the temperature suddenly drops in Victoria, okay, energy will flow out of the water and into the air. And that'll help to regulate the temperature, because the temperature of the water isn't going to change by more than a couple of degrees, whereas the temperature of the air could change by many degrees, 10, 20 even. Okay? But because the ocean is right there, it regulates and moderates those fluctuations in temperature that we can get here. Right? I mean, we've seen there's times where, you know, we wake up in the morning, it's minus 25, and a Chinook blows in through the day, right? And by the end of the day, it's 10 degrees or 12 degrees Celsius. Okay? People who are uninformed, like Leonardo DiCaprio, call that climate change. Okay? We call it weather. Okay? Because that's what it really is. Okay? It's a Chinook, and it's a short-term thing. Okay? And it happens quickly. We know that because we live here and we're intelligent. Okay? But people, they don't understand that, right? But we do. Okay? And so we know that we can have massive changes in temperature. But in Victoria, or Vancouver, or California, where Leonardo DiCaprio is from, okay, they don't get those fluctuations because they're near the ocean. So they don't understand that these fluctuations are natural. Okay? There's not a buffer like the ocean here. We don't have that buffer.
This is why when you I feel like deep sea fishing, like up in Alaska, why the water can be like 3 degrees while it's like minus 30 out.
Absolutely. Yeah. Okay, so yes, the ocean will stay, yeah, and it'll get foggy. You'll see like steam and stuff like that. Yeah. All right, so distribution to land and sea, that's a big factor. Okay, it's why coastal areas typically have more mild climates, okay, than do continental areas. But obviously there are exceptions to that. Okay, if you've ever spent any part of the winter on the east coast, it can be very, very cold. Okay, it all depends on the nature of the ocean currents. Are they bringing water from the Arctic Ocean, or are they bringing it from the Pacific Ocean? Okay, it makes a difference where your water's coming. Okay, other special ocean currents could be things like El Nino and La Nina. Okay, we know if we have an El Nino year, that's going to be one of those years where it's going to be, the winter will be very mild. La Nina was kind of like last year, where we have a really cold hot winter. It's very long, with the snow, okay, things like that. All right, distribution of mountain barriers. This one affects us a lot, okay? Probably third place from latitude and altitude. Distribution, or presence of mountain barriers is probably the next thing affecting our climate here, okay? And it affects our climate because we're in what's called a rain shadow. Okay? Moist Pacific air doesn't always get over the mountains to us. Okay? Sometimes it does, but not always. Okay? And the reason for that is, as that warm, moist air hits the mountains, it gets pushed up, okay? And the temperature goes down. And so a lot of the moisture that's in that air condenses and falls as rain on what we call the windward side of the mountains. Okay, so this is the windward side. This is what we call the leeward side. Okay, we're in the lee of the mountains. Okay, so all the moisture falls on this side of the mountains, and then by the time the air gets over the top, it's dry, it's cold, okay, and as it runs down the mountains, it warms up. Okay, it picks up energy, kinetic energy from gravity, pulling it down the mountains. That gravity can actually, the gravitational potential energy turns into kinetic, which can become thermal energy, which can lead to this warm, hot air coming rushing off the mountains. Chinook. That's what a Chinook is. Okay? That's why we get them. Right? It's just energy of air that's moving down the mountains. Okay? And certain pressure changes as well. But okay, that's a very localized phenomenon. Okay? If you go down, into the States and you use the word Chinook, they look at you like you're speaking a different language. You are. I mean,
It's Canada English.
well, no, it's not. I think it's
Canadian.
Cree, I think. But anyway, it's a local phenomenon. Okay, we get that here. There are other places in the world that have similar phenomena, but they call it something else. Okay, but we call it a Chinook, and it's a very common thing here, but it's not common everywhere, and it's because of the presence of mountain barriers. This is also why our climate here is quite a bit drier than it would be in northern Alberta. Okay, you go, to Grand Prairie or something like that, and they're less affected by the presence of the Rocky Mountains than we are. Okay, so they get more moisture. Right. This is typically why you see grasslands and deserts on one side of mountains, and you see lush stuff on the other side. Right? So if you go into BC, you go over the Continental Divide, and you see all that kind of lush rain, like temperate rainforest. Okay? And then on this side you see prairie. If you go further down into the United States, okay, you'll see like in Washington and Oregon, there's like, again, that tropical forest, and on the other side there's like almost desert with Utah and Nevada and Arizona and places like that. Okay? Those are in the rain shadow of the mountains. The Gobi Desert, okay, in Asia is in the rain shadow of the Himalayas. Okay? So you get these big deserts, okay, that are in the rain shadows. Okay, questions on the effect of mountain barriers? No? Okay. Okay, pattern of prevailing winds. Where your wind comes from typically is also going to affect your climate. Our wind typically comes from the southwest. Okay, and we'll go over in another lesson why that is. But if it's usually coming from the same place, it's usually bringing you similar types of weather. The issue with Alberta, and why we have that expression, if you don't like the weather, wait 5 minutes, is because we're kind of at a point where winds can change direction. Okay, and we're influenced by a lot of moving air masses. So these two factors tend to work together. Right? Typically for us, we're going to have warm air coming in from the southwest, kind of like this. Okay? But occasionally, polar air can move downwards. You guys have all heard the term polar vortex, right? Okay? So polar vortex can bring winds that go the other way. Okay? So what can happen is we'll get low pressure areas, like right in here. Okay, this here is called the mother low. Up here is called the Siberian high. They're typically always low and high. Okay, what can happen is you can get an air mass that comes in off of this low pressure area that's full of moisture and warmth, and it'll interact with something that's coming off of this high pressure area here. When they interact, they usually interact right along here. Right along Highway 2. Okay, that's why Highway 2 is always a mess when the weather changes. Okay, because everything, that point of interaction between the high pressure area in the north, the low pressure area here, kind of in the armpit of Alaska, okay, that's where they always interact. Okay, because the prevailing winds are always pushing those air masses towards each other, and they have to. This is where that interaction and that balancing occurs. The balancing occurs right over top of Alberta. Okay, so we can see rapid changes in weather simply because of where we're located.
Because there was this one day I was just watching the news or something, and then like in West Calgary it was like +4 or something in the morning, and the other part is like -11.
Yeah.
In the east and the front. So
Yeah, if you're right on that Chinook Arch band, right? If you're right underneath that, that's, yeah, you're on the other side of it, it's cold. And we see it in the summer too, right? I mean, the day we got that really bad hail in 2015, or 2016, that June, okay? Yeah, it was down by Costco. It looked like it had snowed a foot and a half. Right, like there was hail, and it was all big and piled up. The gutters were like the drains couldn't drain or anything. Yet over on the other side of town, there wasn't any hail at all. Okay, this is just weird, right? It's really highly localized. Okay. All right, so does that make sense? The prevailing winds and high and low pressure. Okay. So typically if you're in an area where there's low pressure, there's going to be a lot more moisture. High pressure areas are going to be typically drier. So when it's minus 40 here, okay, it's usually clear. Right? That's one of those really cool days where you look outside and you see the sun shining, the sky is blue, and like, oh, it's going to be so, oh my God, what happened when you open the door? The air hurts my face. Okay, it's one of those days. High pressure area, no moisture. Okay, higher pressure makes it drier. Okay, and so as a result, you're going to get much colder. Okay, typically lower pressure areas are going to be warmer and full of moisture. Okay? So that's why we see that this area in here is typically quite wet. Okay, whereas over here, this area is typically quite dry. All right, so those are your factors affecting climate. We're going to quickly look at climatograms because tomorrow we're going to start the activity on climatograms and factors affecting climate, etc. Okay, so these are the climatograms of 3 different places. They're all quite different from each other. Okay, the first climatogram is from Mount Macquarie, New Guinea. It's in a tropical rainforest. Okay, so a climatogram is set up like this. On the bottom are the months of the year. Okay. On one axis, and there's no defined rule for this, but on one axis you will get precipitation in centimeters, and on the other axis you'll get temperature, okay, in degrees Celsius. So in this graph here, temperature is on the right and goes with the green line, and precipitation is in orange and goes with the bars. Okay. So we can see that in this tropical rainforest, okay, there are some months that are wetter than others. Okay, so their wettest month is April. No, March. Is March. Okay, and they get 33 centimeters of rain. Okay, if we would ever get 33 centimeters of rain in a month, we'd be 2013 all over again. Okay, because we only got, what did we get that one? We got like 75 millimeters. Or something like that in the space of a couple of days. Okay, that's 7.5 centimeters of rain. Okay, and look what happened. Right, they're getting 33 centimeters of rain in a month. So it's typically, a tropical rainforest does undergo a lot of flooding. Okay, their driest month is still like 11 centimeters of rain. That would be like the wettest month of the year here. Okay, so much wetter, but there's variation in the amount. There's kind of a wet season and a dry. Okay, there, right? But what do you notice about their temperature? It basically never changes. It stays around 25 degrees all the time, right? Now, where would that be located on Earth? Right on the equator, yeah. Okay, New Guinea basically straddles the equator. So, when you're near the equator, you don't see a fluctuation in your temperature because the amount of sunlight and the directness of that sunlight doesn't change. The tilt of the Earth doesn't make any difference to you if you live at the equator. It makes a big difference to us, which is why, as you move away from the equator, you start to see the temperature make a bell curve. All right? Now, this is Nashville, Tennessee. Right? So further south than us, but mid-latitude United States. Right? So it's got a bell curve. There's definite seasons. Okay, summer can be pretty hot, 28 degrees, but winter is pretty mild. Doesn't even get below freezing. Right? You go to Anchorage, Alaska, you still have a bell curve, but look at where it shifted to. Okay? Now Anchorage, Alaska, because it's near the coast, it's quite a bit more mild than other parts of Alaska. Okay? It gets down to about minus 10 okay, in the wintertime, only gets up to about 15 degrees in the summer. Okay, so if anytime you see the bell curve, you know you're moving away from the equator. If there's less of a bell curve, you're close to the equator. If your bell curve looks like this, where are you? So, yeah, that's what it would be if you were in like New Zealand or something like that. Okay, you would have the bell curve that goes the other way. All right, now, what we can see here with Nashville, Tennessee, like we said, definite seasons, okay, and what's the rainfall like? It's even, right? Like there's, certainly there's some months that are a little wetter than others, but not like this, okay? And in Anchorage, okay, a lot less precipitation, and probably a lot of it falls as snow, okay? This stuff might not, or it might be close, okay? But it's certainly going to be less there. So tomorrow, we're going to start an activity where you're going to be given the climatograms for various Canadian cities. You're going to group them based on their similarities. Then you're going to be looking at their locations, determining what factors affect the climate, and then kind of coming up with some climate groups from there. Okay, so that's generally what we'll be looking at over the next 2 class days. If you're not going to be here, it's going to be posted with the instructions and all the data. You'll be expected to do it on your own. Okay? All right.